Okay, so we're looking at this model, and you've done a LEAD 4.1 option 1 daylight availability study, and you're wondering why it doesn't seem to be working. You're not getting any credits, and you have a really low outputs here, and so you're confused by that. Let's then review um, what we're talking about here. This is a LEAD 4.1 option 1 study. So what is that? So first, LEED is a certification standard for sustainable buildings. There's a lot of sections to it and a lot of different credits. We're just talking about the daylighting credit, and the daylighting credit itself is pretty straightforward. We're using option 1 because option 1 allows us to add blinds, and it's one of the options in Climate Studio. So I chose to use it for this purpose. There are two basic variables that we're designing for in LEED 4.1 daylighting. The first is called SDA, and that is spatial daylight autonomy. And what the benchmark means there is, so spatial daylight autonomy is just, do we have enough daylight to be in a space to be autonomous? And so the metric itself is 300 lux for 50% of the occupied hours. And if we have that for 75% of the time in an average of the entire space, the entire occupied space, then we get this credit. Um, and remember that we're talking about, so when we say lux, what is lux? This, our trusty old diagram that I don't know how long this has been around, but we have a light source. It's giving off light in a sphere coming off of it. That is we measure that in lumens, and then the amount of energy or the amount of light in a direction is going to be candela. So lumens is the full sphere coming off. Um, if we're saying I'm talking about how much light is in a direction, in other words, meaning toward, for example, a work surface, um, that's candela. And then if we go even a step further and we say how much light is hitting a square meter of a work surface, that's 1 lux. So we're talking about the amount of light coming off of a light source and hitting our work surface. We need 300 lux um, for 50. Let's go back. So we're looking at the actual. So we need 300 lux for 50% of the occupied hours, for the average of all the occupied spaces in the area, for 75% of the regularly occupied floor area. It's average. That's spatial daylight autonomy, and that's the green stuff in our, that's the green color in our lead analyses. And we can either look at this. So this is the actual number we're looking for. We want that to be 75%. And you can set it for an annual, or you can do individual days, but this number doesn't change. I'm talking about if you're looking at the outputs in Climate Studio. Then the next, so that's saying, okay, do we have enough light? Then annual sunlight exposure, typical weird naming convention where it doesn't have, why is it spatial daylight autonomy for is there enough, and annual sunlight exposure for is there too much? I don't know. They don't seem related, but they are. Where the orange in Climate Studio is ASE, and we're saying if we have 1,000 lux for 250 hours or more in a space, um, for more than 10% of the occupied hours, then we have um, that's too much daylight, and we don't meet the credit. So, and this is for individual spaces, not for the average. So if we're then looking at, this analysis here, and we say, oh, we're at 8.5%, then we're good. That's not true because there are some spaces down here that are actually at 32 or close around 30% ASE. We need to get below 10. So In this case, we need to be looking at each individual space. Now, you'll notice right now, though, that we still have our 3 points of credit in this output from Climate Studio. That's because we may actually want more than 10% ASC in a room. For example, if we had a greenhouse, we would want way more than 10%. Or we'd want a lot of light in there, right? So this is a narrative-driven um, certification or credit. So we could say this part of the building is a greenhouse, so we took it out of the calculation, or we could make arguments for why we had more than 10%. So in our outputs, we don't lose the credits here just because we have more than 10% in some rooms, because we may want to make a narrative. That's why they look this way in the outputs. But the point is that we have just those two um, variables that determine whether or not we're getting our, which is your mo, whether we're getting our lead 4.1 credits. So that's what we're trying to accomplish here. And we have SDA, ASE, and Lux. Now, the average Lux is not part of the standard, but it's very useful for other things. And so you're right. Well, why do you have such a low outputs here? And is there something broken? Well, let's look and see. If I go, so what you decided to do was um, isolate individual rooms and run analyses. That's fine. That's not going to give us an actual lead 4.1 score because we need it for your entire building. So we'll talk about that in a minute. But why is this happening? Why are we getting so little light in here? First of all, by the way, most of the, if not all of this, or a lot of this light is coming through this door, which you did not glaze. So you either need to make that an opaque opening or put a piece of glazing in there, because right now that's just light coming through and heat going out. Um, but so we clearly don't have very much in terms of lead credit. Well, actually, ASA of 0 is great. We don't want to ever have AFC if we if in a unless we have a reason for it, like a greenhouse, like I said. But we need a lot more daylight to get credit here. However, we do have some amount of lux in the room, right? And is that very much? First of all, this is mostly coming from this door, so it's not going to be a very well lit room this way. Um, but let's just remind ourselves. Let's see if I can find, here it is. Um, that it's a that daylighting is a general term for, like, are we generally getting enough light to make this a well-lit space so that people, first of all, so we can save energy not by not having electric lights on very much, and people inside would be enjoying the other benefits of daylight. But if we start talking about, but what about actually what we're doing in the space when we're working at a work plane, like a desk, or if it was a basketball court, it'd be the floor, I guess. How much light do we want on that surface to do the work? Then there's other charts for that. And here's just an example of one. And the point I'm making here is that it's not a lot of lux compared to what sometimes we're getting in our analysis in Climate Studio. The only one that's over 1,000 is if we have, I mean, even as an acceptable amount, is if we have a professional laboratory where we're really doing fine work and we need a lot of light. Typical, library stacks 2 to 500 lux, an office 3 to 500, um, and there are some where 100 lux would be acceptable. So this isn't like a trivial amount of light that's in this space. It's just not getting us our daylighting analysis. I mean, our daylighting credits. But still, it is low. Why is it low? If I go look at your choice here for glazing, you picked call wall, a specific call wall. And what are its specifications? First of all, you have a T-vis of 0.15. That means that 15% of the visible light spectrum that's hitting the glass is getting through. So only 15% of the visible light is getting through that glass or that material. That's not very much. That's almost opaque. We have a solar heat gain coefficient of 0.13. That means almost no heat is getting through this call wall. And we have a U value of 0.049. So if we're used to, which is the way we look at windows, but just so it always helps me to do an R value. If I had to go 1 divided by 0.049, That's an R value of 20. That's a really good wall. I mean, not a passive house level, but for many purposes, that would be a very that would be a plenty of U value or R value for an assembly. So basically, this you've chosen something that's almost an opaque wall, and that is why we don't have a lot of light coming in. So if I go back, and so let's just look around and see if that makes sense what I'm saying. And it does, because if we go to the courtyard, then all of a sudden we got all this light. And if I turn this on, but now you might think, well, yeah, but that's broken. It's just red, you know. But remember, this color is just because of whatever it's the range you're setting down here. So if I set this at 30,000, now I've got a sensible, that's even too much, right? What was we were at like 18. I thought we were at 30. That's interesting. Let me put this at 20. And now this makes sense because this is a south-facing wall here. Um, so, and we can come in here and actually, oh, and that was already on an annual there. And I should have, uh, so I should go back and look at your floor over here at an annual. So annually, this is what it would look like. And if I go to a specific day, I can scroll through and see if it makes sense. Okay, in the summer, I have a lot more. Hot, the sun's higher in the sky. In the winter, I'm getting that southern wall is starting to block it, and some days it's really blocking it because it's cloudy. And so I'm getting this makes sense. I'm getting much less sun in there in the winter, more in the summer. It's probably the opposite of what I want in there, so that is an issue, but it's not, it's functioning. And then if I go to my other rooms that you've run, this one over here, and let's go back to our 2000, and I'm going to set it on annual. Um, we're getting some light in there. It's not, I mean, it's not a lot, but it is light, and it's a north-facing wall with call wall in front of it. That makes sense to me. The corridor here, something similar. Uh, and then, so what I did, so I'm saying that's, and actually, let's just go back to gymnasium, because remember, I had this on an average. I mean, I had it on a specific day, so we actually have a lot more light in here than I even was saying on an average. Anyway, then what I did is I changed this to clear, just single plane clear, which would be the biggest contrast I could find, because it's going to have a really high um, TVIS, 88%, 82% solar heat gain coefficient. So there's just lots of light and heat coming through, a low U value though. And if I run that, I get more what we're used to seeing, a lot of light in here because we chose clear um, glazing, right? So this design has this kind of daylighting performance when it's clear glass. And so now we really are, we've got plenty of daylighting. Um, and but there's a lot of places where there's way too much, and we'd have to come in and figure out how to fix that. Maybe that's where we would put Calwall here and not have Calwall other places, because we can change the glazing however for any pane can be a different glass, a different material choice in the pane next to it. Um, so that leads us to the question of how should you run this right now for at this point in what we're doing? Um, I think we decided, I mean, I don't, I think I might have even said something different to Sabrina, because it really doesn't matter at this point. But I think what you and I were saying was that the 90.1 um, initial simulations that we're going to run for the thermal, you were going to use the envelope you had in your project, and that would include the glazing. And so whatever that is, I think you should use that also in your 90 your basic your first daylighting study. So you need to decide, or so if you had chosen call wall for your studio project, then you should use it and just go run a daylight analysis, lead 4.1 of the entire. Um, Let me just even turn off. By the way, I changed I just put all your layers inside of um, a single master layer, so I can turn it on and off. I would always suggest doing that. It makes it much easier to control things. And I, usually I would have, obviously this is from the architectural design. Often just copy those layers and put them into daylighting, and then I can take some of them out and not use them all. But then I have separate tools to use for my daylighting and my thermal analysis that are coming from the architecture. Um, anyway, so I would like you to choose. I don't know your design well enough, but looks like it's at least 2 floors. And I would leave. So we're saying occupied areas. It does not include outdoor areas. So you can do daylighting analysis on your outdoor courtyards and this walkway here, or patio, whatever you're calling it. Um, but don't include those in a lead analysis, because it's just what's inside is is what daylighting is really talking about in that context. And so then run that with the envelope, and including the glazing that you chose for your project. If you did not choose one, then yeah, you should probably use the default. But what you did is you used call wall here, and then I was noticing I looked at both of your um, thermal models. Which one is this? This is the 90.1, and here you're using um, the default glazing, which is really bad. I mean, it's got a really low U value and a high, so it's just basically it's probably a single pane or uh, single pane of clear glass. Um, so I don't, you're not going to do that. So that's actually illegal now to use that glass in this context. So for your thermal analysis, I would go back and just change this to, if you're using Caldwell in the other in your daylighting, and that's what you designed the building to have, then use Caldwell here on the thermal analysis too. Um, if not, we can talk about it, but those need to be lined up. I would say that this first analysis that we're running, that's kind of a 90.1, so it's better than your baseline, but I mean, than what you designed, but you're bringing in some of the elements from your design, um, like the envelope and the glazing. Um, and that once you get those two things, then you can move on to the next, whatever the next simulation workflow is that you want to do. Okay, so I think that's all I need to tell you. Let me know if you have any questions, and I hope this helped.